In this lesson, we're going to be graphing different equations, different XY equations by simply plugging in numbers. And what you need to understand before we start graphing, and a lot of people don't understand this because they just learn the shortcut ways and they don't really know what they're doing. But a graph is a set of numbers that you place into an equation and then numbers that you get. So what we're going to do is we're going to place, I've got them circled here, any of these numbers, and you could actually go to, bigger numbers or smaller numbers, but this graph only goes from -10 to 10. So we're going to pick any of those numbers we want to and place in this function. We call these the x's. So we're going to take any of these numbers, put it in for x, we're going to solve it, and that's going to spit out a number. It's going to spit out a y value. And honestly, when you're looking at an equation, you don't even have to have that y equals there, but you're looking at an equation like 2x plus 3. We're placing numbers into this, and we're simply seeing what we get. For example, if I put a 1 into this, we now have 2 times 1. Remember that anytime you have to place something in, you have to take something out. So we're taking the x out, putting in its place a 1. So we now have 2 times 1 plus 3. So when I put in a 1, I get a 5. So on a graph, this is represented by a single point. Again, these are the numbers I put in. So what I'm going to do, I'm going to go over to 1, where 1's located, which is right here. And I know that when I put a 1 in, I get a 5. So we go over to 1, and whatever number I get out, I go up or down to that number. If I get a negative, I would go down. We continue doing this. If I put in a 2, I have 2 times 2 plus 3, which is 7. So again, I put a dot, I go over to what I put in, and I go up to whatever I got. So when I put in a 2, I get a 7. We continue doing this. 0 is always an easy number to plug in. 2 times 0 is 0, plus 3 is 3. Now, we should notice a pattern after a while. And we do see a pattern here when I put in a -1, and we can actually predict what we'd get. When I put in a -1, I bet I would get a 1. When I put in a -2, I bet I'd get a -1. Because, again, look at a pattern. Down 2 over 1, down 2 over 1. And that's going to lead us to the shortcut we can actually use. So this is a linear equation. So once we get all these dots placed in, we simply connect the dots, and we have our graph. Okay, next up, I'm going to graph 1/2 x minus 3. And I'm going to do this one just to show you sometimes if you're cautious about what you plug in, it makes the problem a little bit easier. So in this problem, I'm doing half of x, or 1/2 times x. And I do want to remind you that 1/2 times x is the exact same thing as 1/2 of x. The word of in mathematics, when you're talking about decimals, fractions, percents, the word of means times. So I can actually, instead of thinking this as 1/2 times x, I can think it of as 1/2 of x. So my recommendation, why not plug in even numbers? Because if you're having to do half of something, it's a whole lot easier to do half of an even number because you're not going to get decimals. So let's start with 2. We're going to do half of 2, which is 1. When we subtract 1 minus 3, we get a -2. When I plug in 4, we do half of 4. That's 2. When I do 2 minus 3, don't forget about this minus 3. When I do 2 minus 3, I get -1. Half of 6 will be 3. 3 minus 3 is 0, and that's what we're going to call the x-intercept. If I go the other way, half of 0 is still 0. When I subtract 3, I get -3, and that's plenty of dots because you start to see the pattern, the down 1 over 2 pattern, because this is, again, a line. So you can use that pattern to find other points. I could go up 1 and over 2, and that'd give me another dot. So there's your linear equation. Okay, next up, I'm going to graph a different type of equation. This is called a quadratic equation. Now, I'm going to give you some hints and tips as we go along of how to graph this. Again, if you don't want to worry about the y equals, that's fine. So anytime I'm dealing with equations, I always find my plus and minuses. And what the plus and minuses does is actually divides my equation into 3 separate problems, 3 separate smaller problems. And then whenever I'm plugging numbers in, like, for instance, if I wanted to plug in a 3, I'll plug it into all 3 of these smaller problems. And that gives me a 3, an 18, and a 2. 3 plus 18 plus 2. And when I plug that in, I get a rather large number. I think I get 23 there. And notice that you can plug in anything. But just a quick reminder, sometimes whatever you plug into won't even fit on your graph. So even though it is part of the graph, it's not gonna fit on our picture here. So I would plug in numbers smaller than that, like maybe 0. 0 is always the easiest thing to plug in, and I get 0, 0, and 2. When you add those together, it gives you 2. If I plug in a 1, that'll probably give me a fairly small number as well. That's going to give me, just a quick reminder again, we're just plugging it into each part of my function. So it's going to be a 1 plus a 6 plus a 2. When I plug in a 1, I get a 9. So that's the number that I plug in is here. The number that I get is up here. And I already see, again, why when I plug in 2, it goes off my graph, because you can see how it's going uphill right here. So I'm going to go the other way now, and I'm going to plug in -1. Now, some things I want to remind you of. When you do -1 squared, a negative times a negative is always a positive. So a -1 times a -1 is a 1, a -6, and a +2. Now, when you're adding these, I want you to start thinking about money and debt. So here's all the money you got. You got $1 plus $2, because both of those are positive. But unfortunately, you lost $6. So you had $3, you lost 6. Now you're in the hole, $3. So when I plugged in a -1, I got a -3. When I plug in a -2, and it looks like we're going to have to plug in several numbers here, but I do want to point out that this is not linear. If you look at a pattern here, you go up 5 and over 1, then you go up 7 and over 1. So definitely not a linear pattern. So when I plug in a -2, let's plug it into all three spots. I get a 4, I get a -12, and I get a 2. The money that you have is $6. Unfortunately, you're in debt 12, so you're still in debt $6. So when you plug in -2, which is right here, you go down to the debt that you have, which is -6. Now, good things are about to happen. When I plug in -3, it gives me a 9. A negative times a negative is a positive. A -18 and a +2. 9 and 2 gives you 11. If you subtract 18, that gives you a -7. So when I plug in -3, I get a -7. Now, this next dot, you're going to see something happen. Because, again, this is quadratic, and you're always going to have what's called a parabola when you graph these things. X squareds will always be this parabolic shape. Now, if you were to take away that x squared, I want to point out that, notice, that's what we graphed these last two problems. That was linear. So let's plug in, like I said, a -4, and this is going to be much better what's about to happen. When you plug in -4, it gives you a 16, a -24, and a +2. 16 and 2 is 18. When I subtract 24, it gives me -6. So when I plugged in -4, I got -6 down here, and you start to see it coming back up. Now we can follow the pattern. Notice that you go up 1 and over 1, you go up 3 and over 1, you go up 5 and over 1. So this thing will be symmetrical. So if you went up 1 and over 1 to get this point, then you're going to go, and let me scroll down. I lost my graph there. Let me find it again. If you went up 1 and over 1 to get to this point, then you go up 1 and over 1 to get to this point. You have perfect symmetry, so from there you went up 3 and over 1, so do the same on the other side. Then go up 5 and over 1, then go up 7 and over 1, and you don't have to plug in any more points. And then you see that you have what's called a parabola. Connect your points, and there's what your graph's going to look like. And there's your other side. A couple of things to reference. X-intercepts is where your graph crosses the x-axis. Just to do some house cleaning here. Y-intercepts is where it crosses the y-axis. This lowest or highest point of a parabola is called a vertex. Just thought I'd throw that in there for this lesson. Okay, one other point of caution where a lot of people miss these problems is anytime they have a -x squared. Because what they're bad about doing is, let's say that you plug in a negative number like -3. They'll say, oh, you got a negative out front, -3, that's going to be a +3. But here's the case. You have to, on these problems, you have to square the number, then you have to take the negative of it, according to order of operations. So when you plug in a -3, we know that that number squared is a -3 times -3 is 9, and then you have to make it negative. So if you plug in a -4, you would square it and then make it negative. That's what -x squared means, so that'd be -16. If you plug in a positive number, same thing. Let's say you're plugging in +4. You're going to square it first, which gives you a 16, then make it negative. So that would also give you a -16.